Heat loss response. On a scorching summer day, the ambient temperature is 42 degrees Celsius, yet my body temperature can still stay below 37 degrees Celsius. Why is that? This is what we will learn today. The body's heat loss response. The primary site for heat loss in the human body is the skin. A small amount of body heat is lost through exhaled air, urine, feces, and other excretions. During labor or exercise, sweat glands secrete sweat, increasing heat loss through water evaporation. The body loses heat through the following methods: radiation, conduction, convection, and evaporation. Radiation is the transfer of body heat to cooler objects in the environment via thermal radiation. The amount of heat lost by radiation depends mainly on the temperature difference between the skin and the surrounding environment. When skin temperature is higher than the ambient temperature, a greater difference leads to more heat loss by radiation. A smaller difference leads to less. On a hot summer day, the cool feeling you experience when moving from the blazing sun into an air-conditioned room is provided by radiative heat loss. Additionally, radiative heat loss depends on the body's effective surface area for heat loss. The larger the effective area, the greater the heat loss. Because the limbs have a large surface area, they are important sites for radiative heat loss. When it's very hot, people wear short sleeves and shorts to increase the surface area for heat loss. Conduction is the direct transfer of body heat to a cooler object in contact with the skin. The amount of heat lost this way depends on the temperature difference between the skin and the object, the contact area, and the thermal conductivity of the object in contact with the skin. Within the body, because adipose tissue has poor thermal conductivity, heat from the deep body of obese individuals is less easily conducted to the surface, making them prone to sweating in hot weather. Cotton and wool are poor conductors of heat, hence they provide good insulation. In daily life or clinical treatment, water's thermal conductivity is often used for local warming, where ice caps and ice packs are used to reduce fever in patients with high temperatures. Convection is heat loss achieved through the movement of air, or fluid. A thin layer of air surrounds the body surface. Heat transferred from the body warms this air layer. Due to constant air movement, this warmed air is replaced by cooler air, allowing continuous heat loss to the environment. Convective heat loss is essentially a special form of conductive heat loss. The amount of heat lost by convection depends not only on the skin environment temperature difference and the effective surface area, but is also significantly influenced by wind speed. The greater the wind speed, the more heat is lost. The lower the wind speed, the less heat is lost. Using a fan in summer utilizes the principle of convective heat loss. Evaporation is heat loss that occurs when water vaporizes from the body surface, absorbing heat in the process. Under normal body temperature conditions, evaporating 1 g of water dissipates 2.43 kilojoules of heat, indicating that evaporation of water from the skin is a very effective form of heat loss, especially when the ambient temperature equals or exceeds skin temperature. Evaporation becomes the only effective means of heat loss for the body. Dogs lack sweat glands over most of their skin. At high temperatures, especially above their body temperature, it is difficult for them to maintain a normal body temperature. Their sweat glands are primarily on their tongues. So when it's very hot, they need to pant with their tongues out to lose heat. People with anhidrosis, inability to sweat, react similarly to others in cold environments. But in hot environments, because they cannot use sweat evaporation for cooling, they are more susceptible to heat stroke. Students, what cooling measures would you take in a high-temperature environment? Which methods of heat loss do these cooling measures correspond to?